In the previous video, we looked at using the VM support tool to create files for ESX stop replay mode. In this video, we will cover in detail advanced packet capture with the pktcap-uw tool. First, we'll examine the features of the pktcap-uw tool, and then I will show you the various options we have for using the pktcap-user-world tool so that we can capture data at different places in the chain between the VNIC of a virtual machine and either the switch or the actual physical NIC that's connected to the ESXi host. There are various filters that are available as well, so you can filter on source IP, source MAC, destination IP MACs, and so on. So we will explore all those options as well. I think you will enjoy this lab as it goes into some advanced methods that are available for troubleshooting vSphere 6.x. So back in the lab, I'm logged into ESXi 201 hosts, and we're going to look at the packet capture-uw tool. So pktcap-uw. Now normally I would start off with a -help, but if I key in a -help, you'll get a really long list of options, and we will look at the help screen towards the end. We'll just work through a few examples here. So packet capture gives you the ability to capture packets at different points. For example, you can use this tool to capture packets on an uplink, for example, or on a VM kernel port. So we can begin with the VM kernel port because the command is very simple. So we just say --vmk and then vmk0. And when I hit the enter key, you will see the packets flow. Now, of course, you would assume that there is an option to capture it to an output file. And the answer is yes, there is. What would be the format of that file? The format would be your PCAP next generation format. So let's look at pktcap-user-world and see if we can capture packets at a VM kernel port. So --vmk, vmk0, and this time we will output it to a file. So -o/vmfs/volumes/data ore1 2-test.pcap, and I hit the enter key, and these are the packets that are being now written to the test.pcap file. So I hit a control, and this will go on until I disconnect here. So I hit a control C, and it's dumped 32 packets to test.pcap. We can do a quick more of /vmfs/volumes/ we understand the idea. Obviously, you run it into some kind of an analyzer, and the normal one would be a Wireshark. What are the other things that can be done? Let's now look at pktcap-user-world, and this time, let's say we want to actually capture on a direction. So //vm kernel, and we specify the same one, vmk0, and this time we specify the direction. Direction is specified by dir. The value can be 1, which means it's going out, or 0, which means it's coming in. So packets coming in and packets going out. So you can just imagine how useful this is. You can filter on that. Now there are many other filters available as well. So if I put this incoming, these are the incoming ones on that VM kernel port. Hit a control C again and be done with that. So enough of the VM kernel. We are now in a position to actually understand that there are options to specify the output file. There must be options to specify how much of this data to actually capture, and how many of these packets to capture, and the answer is yes. So we do the dir0, and this time we specify a count, say 5 packets, and we snapshot them for the first 50 bytes of the packet. Okay, so we are going to look at the packets coming into VM kernel 0, 5 of them, and we'll take the first 50 bytes of that. And this is much more interesting, and obviously if you know how to read hex, you can figure out what exactly is happening out here. So we've covered a few of those options. It's now time to look at some more advanced options, and it's best done by looking at packet capture, and it's time now to look at the help file. So we say -h and we pipe it to more because this is a very extensive output. Now the most important thing here is this part, to create the session to capture the packet. So what do we do? Now we've looked at direction, that is 0 is in and 1 is out. The stage is also 0 and 1, and what stage means, before a certain point, that would be a value of 0. So pre would be 0 and post would be 1. So pre and post. Now when is this important? Well, it's important because you have in many cases you want to check, for example, at a switch port. If you want to check at a switch port, because you can specify the switch port and a port ID, so using either ESX CLI network commands or different ways, through the vSphere web client, you can look at that as well. So for a switch, you can find out what the port IDs are. When you define a switch port, you can also define whether it's in the incoming direction or the outgoing direction by --dir, but you can also specify whether it is before or after. It is used a lot with these DV filters, which are basically places where one can put software filters into the IO chain. The LIF ID, okay, this is for NSX essentially. This is the logical interface, and that's the distributed router. If there are modules implemented in that chain, the module and the function can be specified. Of course, you can specify the ports. We've looked at counts and the snap lengths. We've looked at out files, right? Trace is hardly ever used except probably by VMware support. Let's look at some of the other options. I'm going to leave this capture point till last because this is where the real power of this tool is. So let's look at some of this. So if you select a switch port, so for example, if you select port, uplink, and ether switch related capture points, then you can specify the switch port ID, as I said, the logical interface ID of the virtual distributed router and the uplinks. There are flow filter options available as well, so you don't have to capture each and every packet. You can specify based on matching source MAC, matching destination MAC address, or any MAC address, whether it is source or destination. You can specify the various types, ether types. So it is you can actually check to see what kind of traffic is actually flowing on there, and I would recommend you looking at the eth type just to Google on this, and see the various Ethernet types that are available, and of course on VLAN IDs. But not only on VLAN IDs, it's also on VXLAN. So this is really useful in an NSX environment, for example, or if you have VXLANs implemented using vShield or vCloud Director and so on. You can use the VXLAN ID as well. So the VNI can be specified as well. Obviously, the TCP ports, the destination ports, the source ports, it's all normal stuff. The IP addresses, or whether it's the source IP, destination IP, they're all allowed. Extensive flow filter options. You don't have to capture each and every packet. Now let's look at those capture points. Now this command is really important, rather this option is very important for this because it tells you what the various capture points are. They mean, well, the supported capture points are these. So you can insert dynamic runtime capture points. Again, I would leave it up to people that do internal activities to actually do this. These two are interesting: uplink receive and uplink send. So at the point where a packet is received from the uplink device at the driver side, okay, so it's on the receive side, and then on the driver side at the send side. You can also look at the VNIC. So the VNIC backend to transmit packets from guest and to guest. So this is looking at the virtual NIC backend. Now here we have ether switch dispatch. So this is inside the switch, the function that receives packets for the switch and from the switch. There are pre-DV filters and post-DV filters. These are basically software filters that can be inserted in an IO chain. here is the TCP/IP receive function and the transmit function, and then of course inside the kernel as well. This is for the virtual distributed router, the VDR, and this is also for the virtual distributed router for NSX. So you can see there is an extensive array of capture points that can be specified by using the -- capture option that's available. Now, one other aspect of packet capture is to be looked at, and that is pktcap -uw, and we will do a -h and pipe it to more. Now, apart from the flow filter options that we've seen before, the really important ones are the count, because you usually need to specify a count, and it's best if you're writing to an output file to capture the entire packet, including the actual payload there as well. DV filters can be obtained by the command summarize -dv filter, and this is where you have the capture point -- capture point, right? And and the list of capture points is obtained by the -A option. Now, the stage is important because it is before and after a certain capture point. So you can capture the packet before it may be manipulated by that capture point. It's really important, for example, using DV filters are actually used for different purposes. So if you have an intrusion detection system, for example an IDS, or some kind of a software firewall, especially for example in NSX, you can have the distributed firewall that's implemented in that IO chain, and then you can check to see before and after whether the packet actually passes through or not. So you can check to see whether that firewall is working. Of course, there are other ways to check it as well, but that was simply an example. If there are other third-party products implemented also in there that are checking for different forms of malware, for example, you can actually then again see what the packet looks like coming in and what the packet looks like going out if it's been massaged by something in between. There's a use for it which I really need to check out, but I assume that it would actually work, is when a packet goes into a virtual switch, if we have set up the class of service setting and the differentiated code point setting, which we have covered in previous videos, it'll be interesting to actually see the packet before it hits the switch port and before those COS settings and the DSCP settings are put in place, and then after the switch port and as it goes out the physical NIC to see whether those settings have actually been put in by the switch. I'm pretty sure that should work, but to me that would be a good use case, for example, of this stage before and after. And of course the direction would work as well, 0 and 1. In the example we just talked about, it would be for traffic which would be going out of the ESXi host, which is basically incoming in from the virtual NIC of the guest virtual machine, and then it'll be massaged with the class of service as well as DSCP markings, and then it will be sent out to the physical switch. So a very powerful utility that's not very well known. I would highly recommend that you look at the VMware documentation for it. It will really come in handy for your troubleshooting purposes. In this video, we covered using the pktcap -uw tool for troubleshooting. In the next video, we will look in detail at managing Simple Network Management Protocol (SNMP) support in vSphere 6.x. I look forward to seeing you there.